Have you ever walked home from school and noticed the waste mixed into the soil along the dirt paths? If you look closely at the fields where you play, you will often spot old rusted nails, discarded metal caps, and iron scraps. This waste is a serious problem for our communities. It is dangerous to step on, it prevents plants from growing properly, and it heavily pollutes the soil we rely on.
How can we safely and easily collect these hidden materials to reduce pollution? Picking up every single rusted piece of metal by hand would take forever, and some pieces are buried too deep in the dirt. The secret to cleaning up this environmental pollution lies in a specific integrated science concept. That concept is magnetism.
Section 1. Magnetic or non-magnetic? To clean up our surroundings, we have to ask, how do we actually identify magnetic materials in our environment? Let us define our terms clearly. Magnetic refers to materials that are pulled or attracted by a magnet. In Kiswahili, we call a magnet sumaku. So, a magnetic material is anything that a sumaku will instantly pull toward itself. On the other hand, non-magnetic simply means materials that are not pulled by a magnet. If you hold a sumaku next to them, absolutely nothing happens.
Let us apply this to materials you might find scattered in your neighborhood. On the left side, we have our magnetic materials. These are mostly metals containing iron. Think about the items causing pollution: iron roofing nails, steel bottle tops, or rusted iron sheets. If you bring a magnet close to the soil, these will leap out and stick directly to it. Now look at the right side, non-magnetic materials. These include plastic bottles, dry leaves, pieces of wood, and broken glass. A magnet will not pull these at all. By understanding this difference, you can use a magnet as a tool to quickly pull the harmful metal waste out of the soil.
Section 2. Like and unlike poles. Now that you know how to identify magnetic materials, let us look at the specific forces at work when two magnets interact. Every magnet has two ends, called poles. We label them the North Pole and the South Pole. Notice the rule of magnetism on the left side: attraction. When you bring two unlike poles together, meaning a North Pole facing a South Pole, they pull toward each other with an invisible force. They attract. Now look closely at the right side: repulsion. When you bring two like poles together, like a North Pole facing a North Pole or a South Pole facing a South Pole, they push away from each other. They repel. The absolute rule you must remember is this: unlike poles attract and like poles repel.
Section 3. Magnets in daily life.
How are magnets used in our day-to-day life? Science is most powerful when we apply it to solve real issues in our communities. By collecting magnetic materials, you are easily separating dangerous metal waste from the soil and from non-magnetic plastics. This directly reduces environmental pollution and keeps your community safe. But the curriculum also teaches us something just as important as the science. When we undertake projects to clean our environment, we do not work alone. We work in groups. This requires unity and responsibility. It means communicating clearly, doing your fair share of the work, and respecting your classmates as you take responsibility for the health of your environment together.
Section 4. Key lesson takeaways. Let us lock in the most important facts from this lesson. Point 1. All materials in our environment are either magnetic or non-magnetic. Point 2. When dealing with the force of magnets, unlike poles attract each other, while like poles repel. Point 3. We can use magnets as practical tools to easily separate waste and reduce environmental pollution. With these 3 facts firmly in your mind, I leave you with this final question. Now that you understand the power of the sumaku, how will you use this knowledge to clean up your own neighborhood this week?